Welcome to the IT Fundamentals Training Series. This is your host, Mark Halpton. This is episode 54, and we're going to dive into software development. Welcome back to episode 54 of the IT Fundamentals Training Series. This is your host, Mark Halpton. Today, we're going to talk about the basics of software development. So the book very adequately proposes to you that at the time in which the book was written, at least, that any piece of software that you have, whether it's on your mobile application or on a computer or even an IoT device, was written by a programmer. Now, in 2023 versus 2018, when the book was written, in 2023, that may not be entirely true with the advent of ChatGPT and other automation tools that are capable of creating the software. Nevertheless, the fundamentals that we're going to be talking about here remain the same, whether they are built by an automated system, machine learning system, artificial intelligence, or by a programmer. So let's jump in and let's take a look at what we have here. First of all, what we're going to do is we're going to just talk about the basics of how computer programming is handled. Pages 327 through 330 is what we want to look at. All right. And so if we take a look at, first of all, on page 328 is where we really want to get into assembly language. And it's in there. What you have to understand about assembly language is that it's the very basic or lowest level of code in which people can write. So this is the simplest stuff. You probably have heard me tell my story before of how I got into computing. And one of the things that I tried early on, and when I say early on, I'm talking back when I was 10 and 11 years old, yeah, maybe 12 years old. I tried assembly language, and what I built when I wrote an assembly program was on an Apple computer of making a turtle go across the screen. Now, this is again way back in the early days, back in 1984, or perhaps the fall of 1983 is what we're talking about here. So assembly language is the lowest level of code in which people can write. It is the simplest form of code. It is specific to processor architectures, and so it was used. It's used in those processors. So when we start the computer, for example, we are we've talked about BIOS before. It's and the code that's even behind that is what is running that these days. All right, so that particular code was developed in 1947, and like I said, it's been used on a number of different kinds of systems, including Lotus 123, IBM PC DOS, and my little Apple computer where we had the turtle going across the screen. Now, that Apple computer is not only an assembly language, but it's also called BASIC, and so that may be another term that you might want to take a look at. So as you're dealing with computers, just keep in mind that any type of computer is operating off of a very simple function called binary notational systems, or binaries, which means it's all ones and zeros. Ones being, an on state, and zero being an off state. And if you look at table 6.1, this here is just kind of giving you an idea of what that binary to decimal conversion looks like. Now, I will tell you, for this exam, it's unlikely that you're going to need to understand this binary. You just need to know that it's base 2 or base 10, and that it exists. Okay. But as we move forward and move on into networking, network plus, and even perhaps even in the A plus type of thing, you might need to know base 10 binary type of computing values, just the very basic pieces off the top of your head. So keep that in mind. But I will also tell you that I have never, except for in the networking side of things, and only during subnet masking or similar similar functions like that, have I ever needed to use any sort of binary base 10 type of functions. Any other time I've used it, it's been just for fun, trying to figure things out. So don't spend too much time on your binary base 10 and what's going on in your book here, but definitely read it so that you understand that, and the hexadecimal and the binary notational systems. All right, looking over on page 331, we move on to some programming languages that actually are going to start to be able to compile information. So before we do that, though, we're going to look at working with assembly. And if you read on page 331 and 332, it actually gives you some examples here of working in the assembly language before moving on to compiled languages. Now, the difference between assembly and compiled languages is their complexity. So assembly is that very basic computing language, whereas compiled languages, which have honestly replaced almost every bit of basic that's out there, is a much more complex type of situation. So when you currently write code, there's an example here on page 333, about 3/4 of the way down, where it says public class hello world and an open bracket type of thing. This is the compiled type of language that's on here. All right, so take a look at that and make sure that you understand HTML, C++, or C sharp, as we call it, are all items there that you need to take a look at. All right, so we're going to drop it off there and pick it up in our next episode, episode 55, with interpreted languages and markup languages. And we're going to start going a little deeper on those than we did on these other languages a few moments ago, because that is where we start getting into more modern type of function and start utilizing it. So for the purposes of the test, just reading over and looking at assembly and compiled languages, and taking a look at the exercise. I'm looking at my book here real quick, exercise 6.1, where it talks about converting decimal and other numbering systems, converting those over would be a good exercise for you to follow. All right, well, thank you very much for episode 54. We'll be looking forward to digging in a little bit more on episode 55.